Dr. Krauss, welcome to Real Science Friday. Why do you think there is something rather than nothing?
Because we can see it, first of all. I'm pretty sure there's not nothing.
Yeah, that's...
I'm reasonably certain empirically that that's the fact.
Yeah,
the fact that we're on the telephone today is a good example.
Yes, there are people I debate who would go off on a tangent at that point and deny that we could know anything. But I'm glad that you agree there is something.
Oh, there absolutely is, yes. And then the question, the amazing thing is how it's really, from a scientific perspective, the really important thing is a how question, not a why question, because what we really want to know is how everything we see, the galaxies, the 100 billion galaxies in the observable universe, each containing 100 billion stars, created a Big Bang 13.7 billion years ago, how all of that arose potentially from nothing. And what is the amazing thing is when we look at the universe and measure what we've measured, it is perfectly consistent with a universe that could spontaneously arise due to the laws of quantum mechanics from literally nothing. The total energy of the universe appears to be zero, which of course is kind of what you might expect of a universe that came from nothing. And everything we've discovered seems to point in that direction. Now, it's only a plausibility argument. We don't know the laws of physics back to t equals 0 or before. We know it pretty close. We've been able to, but with our machines at the Large Hadron Collider in Geneva, recreate the conditions of the universe back to about a millionth of a second after the Big Bang, and have made some recent discoveries of a major new particle there. And so, but what we've been able to say is that plausibly, it's certainly plausible, and it doesn't look like there's any need for any supernatural shenanigans. The simple laws of physics will do it.
Now, Lawrence Krauss, you know, as I've just introduced myself, that I'm the pastor of Denver Bible Church.
Yes.
So if I end up disagreeing with you on a point and you're able, with your knowledge, to confirm that there are many scientists who would agree with me, could you let the audience know? Because I might need your help in refuting you.
Sure, yeah, as long as if we're talking science, absolutely.
Yeah, if we're talking science, you're a best-selling author. So I'd like to say to you that this is a well-written book, but that's a bit like telling a girl you met on a blind date that she has a great personality. Because I so disagree with what you write, but between you and Richard Dawkins, you guys concede fully half of the argument to us creationists and to the intelligent design folks. Let's just step back and say,
how can you, the question is, do you disagree with the science? And if so, what's your scientific basis?
I love the science. I'm an amateur. I'm a radio talk show host for 22 years, 5 days a week. I've debated people like Michael Shermer, Eugenie Scott. Back in the 90s, Eugenie Scott was on with me for an hour, and she said the best evidence for evolution was junk DNA. And I said, the Bible teacher, I said, well, Eugenie, don't you think it's too early in our study of genetics to conclude affirmatively that all this non-coding, all those regions are junk? And she said, we have it. We sell the DVD. She said, we absolutely know affirmatively that it has no function. Now fast forward 15 years, and it's the Bible pastor who was right, and one of the world's leading atheists who was wrong. Scientist.
Well, first of all, Jeannie isn't a geneticist.
No,
secondly,
neither am I.
I'm a little worried when people make a mistake and say something, then suddenly it doesn't mean the science is wrong. It means the scientist is wrong.
Well, I agree with that. I agree with that.
To say we affirmatively, I'm surprised Jeannie would say that, because in science we generally cannot.
Right.
Regarding things we don't yet understand, we can't affirmatively argue with certainty about anything.
Well, that's a great point. But you guys have, like you and Richard Dawkins, you guys appeared on stage together recently. You guys have fully conceded half of our argument.
Well, I don't know which half.
Well, let me tell you.
The universe had a beginning. If you want to go there,
no,
I'll agree with that.
Richard Dawkins repeats everywhere he speaks that biology is the study of things that appear to be designed. And to explain what appears to be, on your part, the exquisite design of our universe, you believe that there are trillions of universes, so that ours appears beautifully designed just by dumb luck, because if you have septillions...
Let's stop a second. I don't even use the word believe. Scientists don't use the word believe. I don't believe anything. What the question is, what does the data tell me? What's more likely? What's less likely? What's been ruled out by the data? And in fact, the universe is not particularly exquisitely designed for us. It's exquisitely designed to exist. it could be a lot better. In fact, we probably live in the worst of all universes for the long-term future of life.
Yeah, we're able to observe.
Space is non-zero. If it was zero, the universe would be better.
Dr. Krauss, from our position, you say the sun is in an insignificant corner of our galaxy. From our position, unlike the vast majority of stars in our Milky Way, we are able to observe not only the Milky Way to an extraordinary degree, but the entire universe. We have such an extraordinary opportunity because of where we are.
Well, it's not unique by how you're right. We're lucky. In fact, we're unlucky in a way.
Yeah.
We can observe the rest of the universe, but we can't observe most of our own galaxy. So it just depends. It's like someone who lives on the other side of the tracks. It's always greener.
Well, yeah, but if we were in the cluster, right?
We can see, but we are very unlucky. We can't see what we can't see.
If we were in the cluster where most of the stars are in the center of our spiral galaxy, there would be so much interference, we might not be able to see hardly anything.
Well, the point is we don't exactly know, first of all, the conditions, what life would be like, for example, there. And you're absolutely right that if we were right in the center of our galaxy, probably not only would we not be able to observe anything, but it'd probably be pretty hard for life to have evolved. But because we're in the outskirts of the galaxy, which is probably true for only, say, maybe 30 billion of the 100 billion stars in our galaxy. So we're one of 30 billion lucky stars, if you want to call it that, and that's fine. But, I mean, again, it's one of these things where it would be very surprising for us to find ourselves in a place we couldn't live. You agree with that?
Well, that's
surprising for us to find ourselves
Lawrence,
having evolved.
That's like a doctor saying the reason your father is deaf is because he can't hear.
No, it's not.
It's so much like that.
Agree. It's not too surprising that we find ourselves in a place that's conducive for life. Well, you agree with that statement?
I think that's a non sequitur.
It's
a word game to try to.
It's a tautology, not a non sequitur.
Well, right. The extraordinary unlikelihood, the fine-tuning of the physical properties of the universe, and then the extraordinary unlikelihood.
What fine-tuning you're talking about? I mean, you sound like you're an expert in this, and I assume you're not. But you're just spouting off some words that you've heard. So I'd like to know what fine-tuning you're talking about.
All right, I've been doing the show for 22 years, 5 days a week. I'll tell you, the electron to proton mass ratio, right? It's 1 to 10 by what? 30-some zeros.
No, the electron to proton mass ratio is 1 in 2,000.
1 in 2,000?
Yeah.
The electron to proton mass ratio?
Yeah, it's 1 in 2,000. Yeah, the electron weighs 1/2000th the mass of the proton. It's good we're doing a little education here.
Okay, well, you're absolutely right. I'm not talking about 1 to 1. I'm talking about in the entire universe.
Oh, no, actually there are an equal number of electrons to protons. The universe is electrically neutral.
All right, well, you got me there.
Good, okay.
You got me there. I have to accept your word because...
Well, you don't have to accept
No, on a matter of fact...
I don't want you to accept anything I say.
No, Lawrence, on a matter of fact, you've got your degree from, what, MIT? You were at Harvard, Yale, Case Western, ASU?
Yeah.
By the way, I studied at ASU back in the 80s, artificial intelligence. Mm-hmm. Then I went to McDonnell Douglas Helicopter Company, Microsoft, and been a talk show host ever since. But so, okay, I apologize. I'll correct that. There's the finely tuned parameters, all right? There's the gravitational force constant.
Yeah, it is what it is. But what do you mean it's fine-tuned?
There's the electromagnetic force constant. There's the ratio of the number of electrons to protons.
Which is 1.
All right. So the reason that so many astrophysicists, cosmologists have gone to asserting the multiverse, that there are trillions upon trillions of universes, is because they say ours is such that it is so wildly unlikely.
No,
there's no good reason for it to be here unless there were septillions.
That's not the case. And by the way, the multiverse is very speculative, and essentially almost nothing that I've written about having to do with how the universe could come from nothing depends upon there being a multiverse. We've been driven to the multiverse by ideas in particle physics, which to some extent naturally predict the existence of many different universes. Now, there are certain parameters, and you didn't mention any of them, I think, because you're not aware of them.
Yeah,
there are but in my book I describe them in detail. There are certain parameters, like the energy of empty space, that's very inexplicable. We can't understand why the energy of empty space is what it is.
Yeah, right.
And one of the arguments that's been presented, and it's been done a number of times throughout the history of science, is called the anthropic principle, that namely, something along the lines of what you're saying, namely, if it were any different, then galaxies wouldn't form and life as we know it wouldn't form, etc. So if it's a random event, then if it were any different, we wouldn't be here. Now, I should say that that's a plausible and possible resolution to that problem, and it's motivated in some sense by the possible existence of many universes, which are predicted by many particle physics theories. But in the past, when the anthropic principle has been applied to parameters we haven't understood, we've often found that, in fact, it's wrong, that we understand the parameters. It used to be the case for nuclear forces that they had to be finely tuned so the stars would burn the way they were, and people thought, well, it's just anthropic. Well, now we have a fundamental theory called the strong interaction, which describes the interactions of quarks inside protons and neutrons that explains all that. And so the point is that, your God of the gaps argument, which I'm sure you don't really want to use, suggests because we don't understand something, and some scientists suggest one possibility is that it's a random variable, and it is what it is because we're here to measure it, is one possibility. But the fact that we don't understand it and it's inexplicable otherwise at present means there's a God. Well, that's a pretty bad argument, as you know, because the minute we understand it, your God's going to go out the window.
Lawrence, in your book, as you've just said, you talk about nothing. I mean, you talk about the geometry of space and the energy that fills the geometry of space. But to clarify, you're not denying, are you, that there are physicists around the world who have calculated the unlikely existence of these fine-tuned parameters and have looked at our universe and said that it is wildly unlikely.
No, I actually am denying that.
Are you denying that?
Yeah, I'm denying that because
no
one can calculate the probability answer. There are many people who are saying, look, the parameters of our universe seem rather strange. And maybe they're random, and it would be nice to calculate the probability that they occur. But we don't know the probability distribution over all universes because we don't know the underlying physics of the multiverse. So no one can calculate the probability distribution. If they say they are, they're incorrect.
This is what's driven people to say that there are at least 10 to the 500, 10 to the 500 zeros universes.
You got it wrong.
Go ahead.
The reason that people say there may be 10 to the 500 universes is some people who think that string theory might be a good theory at the basis of quantum gravity,
which you don't
pointed out that string theory predicts 10 to the 500 different universes.
Yeah, and there are other physicists who are saying that number, that's a paltry number compared to the number of universes. There must be virtually infinite.
Well, it could
and then, lo and behold, we find ourselves here in this one where we're able to exist.
The point is, all of that may be true. I don't see what your problem is.
Well, I am surprised. Could I just object for the record that you're denying that there are a legion of physicists who look at the parameters of the universe, gravitational force constant, electromagnetic force constant, and so on, and they say this is very unlikely, therefore there's likely trillions of universes, and we happen to be in the one that supports our existence.
Well,
I'm shocked that you deny that.
It's the case of people who stretch the truth. You've got one or two things right, but your conclusions are wrong. There are many physicists who argue that the parameters of our universe are difficult to comprehend. There are many physicists who point out that there are various fundamental theories that predict the existence of many different universes, and therefore one possibility to explain the parameters that we see is that they are randomly distributed over universes, and we only exist in the universes that allow life. The problem with all of that, of course, is we don't even know what all sorts of intelligent life are. We don't know if the parameters of our universe are vastly different, whether a different source of intelligent life would evolve. We don't know even if we're typical of life in the universe. These are questions that are open questions at the forefront of physics, which is why we continue to look out instead of trying to assume we know all the answers.
Lawrence, here's how it looks to me. By the way, the book is A Universe from Nothing, Lawrence Krauss, afterword by Richard Dawkins. Here's the way it looks to me. When Richard Dawkins joins the discoverer of DNA and so many atheists and evolutionists now, saying that perhaps...
I don't know what you mean by atheists and evolutionists.
Well, there's some people who are atheists, some people are evolutionists, some people are not.
What do you mean by evolutionists?
People who believe molecules to man evolution. Neo-Darwinism.
What do you mean? Well, as I said,
can I tell you what they're saying before
the people who accept the evidence of empirical science.
Yes,
the same people who believe the Earth is round.
Those people. Well, the president of the Flat Earth Society is a Darwinist.
Well,
they operate
fine,
today.
I'm just saying he's an idiot for being a president of Flat Earth Society.
I agree with you. See, we agree on something.
Yeah, no, exactly.
Lawrence,
and all I'm saying is there are no scientists who aren't evolutionists.
Could I make my point?
So you don't believe in gravity.
Could I make my point so you can tell me I'm wrong?
They're on the same level of footing.
When Richard Dawkins and so many atheists say that perhaps because of the complexity of molecular biology, They joined the discoverer of DNA in saying maybe life came here from aliens. They seeded life on Earth. And when physicists are saying there must be trillions of universes, or there might be septillions, or we can't even pronounce the number, it seems that they're merely punting to explain the complexity that we can see. They're proposing infinitely greater complexity. And so to explain one living cell on Earth, they posit alien civilizations, space travel, quadrillions of cells to explain one cell on Earth. Could you agree, Lawrence Krauss, that when they say that, they're merely punting?
Well, I don't know. Again, when it's like you're asking, when did you stop beating your wife? I don't concede that people are saying that. I've never heard people say that.
You have never heard.
Well, I've heard people
How about panspermia?
Hold on. At my institute that I run here at the university, the Origins Project, one of the things we look at is the origin of life. And what people are looking at is specific chemical reactions that could lead to the development of organic molecules. And I don't hear anyone talking about aliens or I mean, there's this idea of panspermia that is an interesting possibility, namely that the first organic molecules didn't evolve on Earth. But
how about Richard Dawkins? I transcribed Richard
I'm with
Dawkins.
Richard Dawkins all the time, and he's never said that with me.
I watched this 15 times on video, and I published the transcription on our RealScienceFriday.com website. Dawkins said that the origin of life, quote, might have come about in this way. The evidence may show, as we look at the complexity, as we look at the genetic mechanisms, that might be evidence that a long time ago, far, far away in another galaxy, that there was a civilization that evolved by Darwinian means, and that civilization designed life and seeded it on our Earth. Lawrence, he actually said a long time ago in a galaxy far, far away, like he's watching Star Wars.
Well, he's not an expert in astronomy. He's probably more likely by a star in our galaxy.
Yeah, right.
Anyway.
So he said that along with, by my extrapolation of the atheist and evolutionist I debate, thousands have posited that life might have come here from aliens, including the co-discoverer of DNA, Francis Crick. I can't believe you've never heard of this theory.
Panspermia. It's a fascinating idea.
Yeah, but do you agree with me that they're only punting because if biological life is so complex that it couldn't evolve here on such a hospitable planet, then why would it evolve somewhere else? You got the same problems there as here. Don't you agree they're just punting?
Well, first of all, the argument, there's no one I know who says that there's any evidence that life is too complicated to have evolved here.
Thousands have posited that life might have come here from aliens, including the co-discoverer of DNA, Francis Crick. I can't believe you've never heard of this theory.
Panspermia. It's a fascinating idea.
Yeah, but do you agree with me that they're only punting because if biological life is so complex that it couldn't evolve here on such a hospitable planet, then why would it evolve somewhere else? You got the same problems there as here. Don't you agree they're just punting?
Well, first of all, the argument, there's no one I know who says that there's any evidence that life is too complicated to have evolved here. But one of the arguments for why it might have evolved elsewhere is our sun and Earth are relatively young. Earth is 4.55 billion years old. The galaxy is 12 billion years old. There are many stars and solar systems that are far older than our solar system. That an additional 7 billion years of potential evolution. So,
could I offer right now to donate $1,000 to a charity of your choice if you could show me a published peer-reviewed paper that actually has scientific observations and calculations within 100 million years that comes close to your 4.55 billion years old?
Oh, we can do it. There's tons of them.
That you agree with the science on. I'll donate. Just so email me, Lawrence. Lawrence, just email me.
The parameters only agree if it's 4.55 billion years old. We can measure the abundance of various elements. And I mean, every single bit of data tells the same thing. You're not a young earther, are you?
Yes, I am.
Oh, well, then
Lawrence,
you shouldn't get in your car or fly a plane
or
use your toaster, because the same laws of physics and chemistry that say how they work tell us that they. I mean,
that's a non sequitur. To go from applied science to origins, you do this in your book a lot. You say because we are starting to figure out quantum mechanics.
We figured out quantum mechanics.
No, we haven't figured out. You sound like Eugenie Scott.
Quantum mechanics, we understand basic quantum mechanics. We understand how it works. We have the equations.
There's fundamental
for the telephone we're using right now.
There are fundamental mysteries about the nature of matter,
that's why
energy,
I study science, because I want to explore those mysteries.
in life itself. So for you to say we really have figured out you don't need God to originate all those things.
Well, I'm just saying that we understand.
You're overselling.
Like you don't need God to make an airplane fly.
Lawrence,
we figured out how it happened.
That's applied science. Then to go to origins, you're overselling your case. Mm-hmm. Just like you do in your book, you say all evidence now overwhelmingly supports the Big Bang.
Well, overwhelmingly is an understatement. All evidence supports that the Earth is round. All evidence supports that there was a Big Bang. All evidence supports evolution.
Lawrence,
all of these things are scientific
I asked
facts.
You earlier to help me. Now, would there be many advanced degreed scientists at leading universities who would agree with me and disagree with you?
No.
How about the 400 scientists who signed over at cosmologystatement.org saying that the Big Bang model, and you know what they signed, right? And I've got it in front of me.
I once with Eugenie made a T-shirt with 500 scientists named Steve.
I know that's funny.
400 scientists to say the Earth is flat.
They have This is from Max Planck.
PhD. That's all it means.
Lawrence, this is from Max Planck Institute, Cornell University, George Mason.
What department?
Lawrence Livermore, Los Alamos National Labs.
Scientists don't argue on credentials. There are no such thing.
Right.
Unlike religion, there are no
How about this?
NASA. Authorities.
How about this?
Scientists can be wrong.
How about this? NASA Kennedy Space Center.
Well,
400.
Okay. Kennedy Space Center
Lawrence,
are also wrong. I've talked to them.
Let me tell you what they point out.
And by the way, there are approximately 40,000 physicists alone in this country. So you're telling me you get 400 nuts in 40,000 people? That's not too unusual.
The way that they're mocked, like by Richard Dawkins, saying the human eye would have been designed by an idiot. And you'd have to be an idiot.
Certainly, if it had been designed, it wouldn't have been designed the way we would have.
That's completely false.
Your evacuation system wouldn't have been designed the way it is, or the way you breathe wouldn't have been designed
Lawrence,
the way it is.
In 2 weeks, I'm interviewing a professor at University of California of ophthalmology, Gary Aguilar. The human eye, the nerve comes out for us in the front and for an octopus in the back. And the reason, according to anatomists who published on this for 20 years now, Richard Dawkins is 20 years behind, is because an octopus doesn't look up at the sky and see the sun. So a bright light, a bright flash like a camera flash, is not going to kill 1 million cells in an instant. And in a human being, we live on the surface. We might glance up toward the sun, just like you go blind for a moment when somebody takes your picture. The blood cells, let me just finish it.
If you set up your TV,
let me just finish the point, Lawrence.
You put the cables behind
Lawrence,
the TV.
let me just finish the point. The nerve comes out of the front of the retina because we need the blood vessels available to quickly regenerate our eyesight. So within 1 to 2 seconds, you could see after somebody takes your picture, and it's called an optimal design by leading anatomists. Optimal.
Look. Let's go back to the one thing you said that is absolutely ridiculous beyond belief. I mean, you've said a number of things.
Well, was that ridiculous beyond belief, what I just explained about the eye?
The details of it are, look, you could still design it so you didn't have to put a hole in it.
No, that's not true. There are trade-offs.
If you don't want to listen to me, then we shouldn't talk.
Go ahead.
Can I say a word?
Sure. Thanks.
Okay. When you hook up your TV, you may have your DVD in front of the TV and you have a lot of cables. You rarely will you drill a hole through the TV to put the cables through. What you'll probably do is wrap the cables around the TV so they don't block the TV. Well, in your eye, there's a hole drilled in, and you could call that optimal. You could call it not optimal. The point is, it's there, and I doubt you would do that to your TV. But look, those are the
I could explain why that's incorrect.
You're arguing for specifics. Let's stand back to go to generalities. How can anyone in the 21st century think the world is 6,000 years old and still consider themselves not a Neanderthal?
All right, I'll tell you.
By that.
All right.
In every single bit of data, we have evidence.
The Neanderthal
evidence of civilizations
Lawrence,
that are older than 10,000 years
Lawrence,
old.
the Neanderthal DNA has been sequenced.
Yeah, I know.
It's closer to you than a chimp is to a chimp within the same species of chimps. So the creationists who've been saying for decades that Neanderthals were people have been confirmed. DNA doesn't lie.
What do you mean people?
People. Human beings.
I mean, our DNA is within 97% the same as an amoeba. I don't understand what your concern is.
Well, that's not true at all, but a sponge.
I ran a meeting on early modern humans, and we're learning a tremendous amount about Neanderthals, who, by the way, went extinct about 40,000 years ago. And it's very difficult to go to extinct about 40,000 years ago
Lawrence,
in a universe that's 6,000 years old.
You know that there's carbon-14 everywhere it shouldn't be, right? Everywhere in diamonds and dinosaur fossils and coal and oil and gas.
Why?
And dinosaur soft tissue.
This is really amazing because, every single thing we teach high school students about the universe contradicts the possibility that the Earth is 6,000 years old, beyond the fact that we have direct relics of cave art that's 30,000 years old. We have evidence of civilizations that are 10,000 years old, and moreover, we have genetic and fossil evidence going back. And everything
we have blood vessels.
4.5 billion years old.
We have blood vessels.
4 billion years old. We have many fossils that are almost 1 billion years old, and we have a tremendous amount of evidence of exactly how life evolved on Earth. And why must people reject all the knowledge we have because they insist that they're
because of dinosaur blood vessels?
Why don't you open your mind to the evidence of reality and say, look, if there is a God, the God, as Galileo once said, if there is a God, he gave us a brain. We shouldn't throw the brain out.
Dinosaurs, papers are running 10-1 against the claim that the soft tissue in dinosaur fossils are bacterial biofilm contamination. 10-1. I'm talking about Nature, Science, Paleontology.
Again, you've got a God of the gaps thing.
No God of the gaps.
We learn our ideas evolve.
Blood vessels, Lawrence, blood vessels don't hang around for 65 million years in sandstone in Montana. Harvard has sequenced proteins.
I've been with Jack Horner in Montana and seen the fossil blood vessels. Yeah. And in fact, it's perfectly consistent with things that are 65 million years old.
Oh,
Jack Horner, who was the person who discovered
How about the carbon-14? How about the carbon-14, Lawrence? There's carbon-14 in the mosasaur fossil that has soft tissue. Harvard has sequenced proteins from a hadrosaur. Carbon-14 can't last 1 million years, yet it is everywhere.
Could it be contaminated? I mean, when you talk about anomalies, you're like the people who
anomalies.
Tell me about UFOs, and they say, there was a UFO sighting in this.
I agree with you.
You can't tell me it didn't happen. Well, you're absolutely right. There are anomalies.
I agree with you, but these anomalies are everywhere.
Ridiculous anomalies when there's a whole basis of knowledge which tens of thousands of scientists have worked their whole life on, not because they're evolutionists or atheists, but because they want to understand nature and make the world a better place. And then people like you come along and say, I want to deny all that knowledge because I've decided in advance of reading anything, based on some book that was written God knows how long ago, that the Earth is 6,000 years old, and no matter what you tell me, I'm going to find an argument not to believe that. That's closed-mindedness. That's not open-mindedness.
The anomalies are everywhere worldwide. There's carbon-14, diamonds.
Look, don't talk to me about anomalies. Talk to me about the evidence of
carbon-14 decays with a half-life of 5,700 years. Right. This is hard evidence. It can't be neutron capture. The USGS shows how rare radioactivity is in the crust of the Earth.
Well, hold on. What do you mean how rare radioactivity is in the crust of the Earth? Yeah. In fact, there's as much heat coming from the Earth due to radioactivity as, in fact, all of the Earth's radiant heat coming from the sun.
And what percentage?
There's a tremendous amount of radioactivity inside the Earth. So I don't know. In fact, it's one of the fields I study. So again, once again,
all right. No, on this, I think I know very much what I'm talking about. 90% of the Earth's radioactivity is in the crustal rock of the continents.
That's a true statement.
Right? And so if the chemical elements were created in stars and supernovas, then all this uranium and thorium and all, it should be evenly spread out through the core of the Earth, the mantle, the oceans.
It surprised me tremendously because when as a physicist, I first thought, the uranium and thorium, which is heavy elements, should be, in fact, in the Earth's core, not in the crust.
Well, I said it should be evenly distributed.
They're large ions, and they float to the surface in a molten Earth.
Okay,
learn your chemistry.
Lawrence, I believe you. Okay. But wait a minute. They should be on the floor of the ocean. They are volcanoes.
No, they shouldn't be on the floor of the ocean because their abundance depends upon exactly whether they're in granite or there's a great deal of potassium, radioactive potassium, K40, underneath the ocean. But in fact, the uranium and thorium is in fact preferentially by chemistry and geology inside granite. And that's just a differentiation.
Okay, now wait a minute.
And people spend their lives trying to understand that. They don't say, you know what? I want to find something. I know in my heart of hearts for no reason except some inner voice in my mind told me the Earth is 6,000 years old. I know that's the case now. They open their mind and they say, let me try and figure out how the Earth evolved, and work it out. And they do, and they work very hard. And I get particularly offended when people come up and try and say, you know what, all of that knowledge for the last few hundred years, I'm going to throw out because I know the answer.
So when NASA last year looked at the isotopes of the sun and the earth, and they found out that the sun had different isotopes of oxygen and nitrogen than the earth, and that was a surprise because they assumed that because all of our matter came from stars in a swirling nebula, there's not a good physical reason why we would have different isotopes.
There's a bunch of surprises. Why is the isotopic abundance of deuterium in the water on the oceans on Earth different than that in comets? It's been a big mystery. Actually, we've come up with some new developments there. There are lots of mysteries, and you know what? We try and solve those mysteries. We don't say, you know what?
Yeah.
Can't understand it, it's God.
Yeah.
You know, that's just a lazy man's way out.
Right. Could I ask you, Lawrence Krauss, and I know your time is valuable. I don't want to take advantage of your kindness. The book is A Universe from Nothing by Dr. Lawrence Krauss. Lawrence, just real quickly, let me give you a list of observations I've made about the Big Bang. You say all the evidence overwhelmingly supports it. Well, there are missing collisions. This is brand new science. In the spiral galaxy clusters, millions of years of missing collisions. The astronomers, astrophysicists are saying it's embarrassing. Their words, they're too perfect. There's missing heavy metal from 1 trillion stars and 15 galaxies. They say there's millions of years of missing heavy metal. There's missing stage 3 supernovas. Spiral arms are not deformed like they would deform in a couple million years. There's a missing echo of the Big Bang. There's a missing uniform distribution of isotopes.
Everything you said is wrong. I study numerical simulations. We are able to reproduce beautifully, in fact, better and better and better, the nature of spiral galaxies. And in fact, because of the spiral arms are stabilized by the existence of dark matter, which is one of the other bits of evidence for dark matter.
Right.
The fact that we in fact are more and more discovering early generation stars with some heavy metals, which are quite interesting, and it's one of the areas that I'm actually interested in because that's the early evolution of stars. One of the reasons we're building the James Webb Space Telescope is to look at the first generation of stars so we can answer those questions. But there's nothing, none of what you said in any way not only obviates the Big Bang.
Well, these are all missing. These are all things that you need secondary assumptions. You need rescue devices. You create unknowns.
We see the Big Bang. We look out and we see the Big Bang. When you say there's a missing echo, go out and look with the microwave background and see the cosmic microwave background, which is measured and is predicted as part of the Big Bang, and is measured to exquisite accuracy. 1 part in a million. It has the characteristics. It's the best.
What, the CMB?
Body background in nature.
What, the CMB? You're saying?
The cosmic microwave.
That's not true. Okay, you say in your book.
You go out and measure it and tell me it isn't true. But you know,
you say in your book.
I've been involved in the CMB for a long time, and I know what's true.
Well, you say in your book, you talk about the distribution of chemical elements in the universe, and you say that, I mean, you use really colorful language. This is the big proof of the Big Bang.
The fact that lithium is predicted to be 1 part in 10 to the 10th.
Yeah, and I have
24%.
And I have so many.
Amazingly, that's what they work out to be.
And I have so many quotes, not only from Nature and physics essays, and from hundreds of scientists at respected institutions that say this, that say those predictions are historically false. They were adjusted after the data was observed and repeated, and this is now being documented.
Well,
Nature,
Nature,
19.
Well, I take personal offense to that because I predicted the abundance of light elements in the Big Bang, and I didn't, and I just did it based on the best physics we could come up with, computer codes and uncertainties in nuclear reaction rates as measured in nuclear reactors. And to say that I fixed the data is obviously an offense to me personally.
All right, what do you say about this? In the journal Nature, 1990, a particular value for the baryon-to-photon ratio needs to be assumed ad hoc to obtain the predicted abundances. That is repeated and affirmed by hundreds of advanced agreed.
Photon ratio. All of the data only agrees for a specific value of the baryon-to-photon ratio. That's how you actually determine things. You know, you measure things, and you see, and you compare with theory, and you see what agrees. That's how we do science. So we've actually measured the baryon-to-photon ratio. And the amazing thing is, We do a completely independent measurement. So we measure it from nuclear reaction data, and we determine that the baryon to photon ratio is a certain number. And then we go out and measure the cosmic microwave background, which is a totally independent way. It doesn't depend on nuclear abundances or anything. And you know what? It gives exactly the same value. Now that is science.
Now, I can't speak to what you just said.
Well,
it
of
does,
course you can't, but
right.
I can.
Yeah, and you can. It does contradict a signed statement by hundreds of scientists.
Yeah, but I told you, don't give me signed statements. That doesn't matter.
Well, they're scientists just like you are, Lawrence.
Scientists to sign a statement saying the Earth is flat. Are you going to run your show tomorrow?
No.
Saying, you know what? We don't really know the Earth is round.
No, the flat Earth guy is a Darwinist.
Decided to sign a statement.
All right.
I mean, come on.
The CMB.
Don't argue on the basis of that.
Let me ask you about the
science.
Let me ask you about the cosmic microwave background prediction. Wasn't it off by a factor of 10 universes? It didn't predict 3 degrees or 2.7, but 30 degrees. And so history shows that these predictions were adjusted after the fact. That's according to William Mitchell.
That's right. It's great you're saying it, but that's not that we actually measure the number. We measure the number, and it tells us what the number is.
But it's adjusted after the fact.
And then we run our theories. And, of course, we didn't know the expansion rate of the universe, and as we measure the expansion rate of the universe, we get better and better ways of testing it. And the point is, don't you understand that some scientists would love to find that all the data is false because they become famous? And the point is, scientists don't do this stuff. And
I understand that.
Where we shake hands and wear hoods and say, look, let's not admit any evidence is false. Because the only way to become famous in science is to prove your colleagues wrong. If we could prove the Big Bang was wrong, I'd win a Nobel Prize for it.
Dr. Krauss, the other way to become famous, the best-selling atheist authors, to me,
Well, they're all atheists, so it doesn't really matter. I don't know what you're talking about.
They're all atheists.
Essentially, the first approximation all scientists are, yeah. Most of them aren't atheists. They don't even talk about it. As my friend Steve Weinberg says, most scientists don't even think enough about God to know if they're atheists. It's just irrelevant to what we do in the laboratory.
You know, U.S. medical doctors are not theoretical physicists, but they're trained in applied science, the biological life sciences.
Yeah, well,
they're not the most ignorant.
Data on who's what.
They're not the most ignorant group in the world, and 60% say God was involved in the origin of life. 60%.
Yeah, but medical doctors aren't evolutionary biologists.
I know that. I just said that, but it's applied science.
Mechanics believe that you know God was involved in the evolution of life. It's a nice statement, but I don't care whether 60% or 6%. I compare what the data tells me. I don't do things by votes or authority. That's what religion does, maybe. But science does things by looking out at the universe. And don't give me arguments about N% of people think this or that. You know what? 40. I mean, the fact that they're more. I mean, it's just amazing to me. If you could take polls of people. Do you know 50% of American adults think the sun orbits the Earth?
No, I don't. Well, I don't believe that.
The National Science Foundation does that study every year. Are you going to argue to me?
I don't, Lawrence.
Hold on.
I don't believe that.
In classes, we should teach that the sun orbits the Earth because 50% of people think that.
I bet you. I bet you not one.
Of education
I bet you not 100th. I bet you not 100th of 1% of U.S. medical doctors believe that. And I don't even believe the study anyway.
You can bet me all you want. I'm giving you a statistic which shows you if you want to take polls of people, you're going to find out the most ridiculous nonsense is believed by many people. And don't use that to validate your arguments. It just demeans your arguments.
Well, I agree with you that the truth isn't up for popular vote. I agree with that.
Okay.
The point is...
And the way we try and find the truth is to rule out... And in fact, science doesn't really, believe it or not, deal with truth. It deals with falsehoods. We make predictions, and if they don't agree with the observations, we know they're false. If they agree, it doesn't tell us it's the absolute truth. It tells us we're on the right track, and we keep exploring more and more and more and refining our ideas. That's why science changes. That's why science makes progress. That's why you can live in a universe now where you can talk to me on the phone or Skype me, whereas 100 years you couldn't, because science makes progress.
Not a single invention. We listed 100 inventions on this show, Real Science Friday.
Okay.
Not a single one required Darwinism. One of the members of the National Academy of Sciences,
well, you know,
Philip Skell, analyzed
natural selection is the basis of many vaccines, and you know,
Lawrence,
you can tell me. I mean,
Lawrence, Philip Skell analyzed
modern biology. You can't do biology without understanding the evolutionary basis.
That's
of
what
life.
Dobzhansky
said.
said.
You can tell me that, but again, it's just as ignorant as the rest of your statement.
Lawrence, that's what Dobzhansky.
I really have a
meeting
where I've got to go.
Could I make a last point?
Well, I've got a meeting with a postdoc and a graduate student where we're trying to actually go and do science.
All right.
I kind of, I mean,
all right.
You know,
Because the national...
I'm trying to argue with you on the basis
You're
of
very
scientific
gracious.
evidence, and you keep giving me this anecdotal stuff, and it's just not worth having a discussion. Because first of all, nothing I'm going to say, no data I'm ever going to talk to you about,
that's
is
not
ever
true.
going to convince you of something that you've already decided is true.
That's not true.
Not the way science works.
That's not true, Lawrence. The New Testament says you can falsify Christianity. Could be falsified.
Great. We have in many cases.
That's not true.
We falsified most of the things in the Bible.
But I am open. Are you open to the possibility that Darwinism is false?
What do you mean Darwinism? You
Evolution.
Like communism. Am I open to the possibility that all of evolutionary biology is based on a false premise? Well, there's that possibility, but it's incredibly remote given the fact that it's the basis of modern...
Well, Dr. Philip...
I am willing to argue that maybe Newton and Einstein and everything I know about physics is somehow wrong, but boy, it'd have to be an amazing conspiracy.
All right, well, Dr. Philip Skell of the NAS said he analyzed 100 years' worth of Nobel Prizes in biology, and he personally interviewed dozens of world-renowned scientists, and he said he could not find one Nobel Prize in biology in a century that depended on the theory of evolution or Darwinism.
He says that. But why do you actually take the National Academy of Sciences, the same organization, puts out a book, which you should get, which actually talks about evolution and explains the basis of it in modern science.
Yes, we went through
the National Academy, that group of the most esteemed scientists in the country, has, in fact, put out a book for the public.
I know.
Explaining the misconceptions that people like you have and why they're wrong.
There's a worldview bias. So people look at origins and they say, we know that you don't need a God. And that's an overselling of what we know.
I don't know that you don't need a God. The question is, do you or don't you? I don't know anything till I investigate it. That's why I'm a scientist.
Well, do you know? Do you know
everything before you investigate it? That's why you're a creationist.
Do you know that you don't need a God for origins? Do you know that?
No, absolutely not.
Very good. Thank you.
Yeah. I mean, absolutely not. And that's why I'm open-minded. But I demonstrate that based on what we see, there's no evidence for it. And that's an interesting result. And I do it with an open mind.
Well,
but
how about the
discovery? Conversation. I appreciate it.
Thank you, Lawrence.
Okay,
God bless.
bye-bye.
I appreciate you.
Point in that direction. Now, it's only a plausibility argument. We don't know the laws of physics back to t equals 0 or before. We know it pretty close. We've been able to, but with our machines at the Large Hadron Collider in Geneva, recreate the conditions of the universe back to about a millionth of a second after the Big Bang, and have made some recent discoveries of a major new particle there. And so, but what we've been able to say is that plausibly, it's certainly plausible, and it doesn't look like there's any need for any supernatural shenanigans. The simple laws of physics will do it.
Now, Lawrence Krauss, you know, as I've just introduced myself, that I'm the pastor of Denver Bible Church.
Yes.
So if I end up disagreeing with you on a point, and you're able, with your knowledge, to confirm that there are many scientists who would agree with me, could you let the audience know, because I might need your help in refuting you?
Sure, yeah, as long as if we're talking science.
Yeah,
absolutely.
If we're talking science, you're a best-selling author. So I'd like to say to you that this is a well-written book, but that's a bit like telling a girl you met on a blind date that she has a great personality. Because
science is wrong. It means the scientist is wrong.
Well, I agree with that. I agree with that.
To say we affirmatively... I'm surprised Jeannie would say that, because in science we generally cannot, regarding things we don't yet understand, we can't affirmatively argue with certainty about anything.
Well, that's a great point. But you guys have, like you and Richard Dawkins, you guys appeared on stage together recently. Mm-hmm. You guys have fully conceded half of our argument.
Well, I don't know which half.
Well,
I mean,
okay, let me tell you.
The universe had a beginning. If you want to go there,
no,
I'll agree with that.
Richard Dawkins repeats everywhere he speaks that biology is the study of things that appear to be designed, and to explain what appears to be, on your part, the exquisite design of our universe, you believe that there are trillions of universes, so that ours appears beautifully designed just by dumb luck, because if you have septillions...
Well, let's stop a second. I don't even use the word believe. Scientists don't use the word believe. I don't believe anything. What the question is, what does the data tell me? What's more likely? What's less likely? What's been ruled out by the data? And in fact, the universe is not particularly exquisitely designed for us. It's exquisitely designed to exist. It could be a lot better. In fact, we probably live in the worst...
Dr. Krauss, welcome to Real Science Friday. Why do you think there is something rather than nothing?
because we can see it. First of all, I'm pretty sure there's not nothing.
Yeah, that's.
I'm reasonably certain empirically that that's the fact.
Yeah,
the fact that we're on the telephone today is a good example.
Yes, there are people I debate who would go off on a tangent at that point and deny that we could know anything. But I'm glad that you agree there is something.
Oh, there absolutely is. Yes, and then the question, the amazing thing is how it's really, from a scientific perspective, the really important thing is a how question, not a why question, because what we really want to know is how everything we see, the galaxies, the 100 billion galaxies in the observable universe, each containing 100 billion stars, created a Big Bang 13.7 billion years ago, how all of that arose potentially from nothing. And what is the amazing thing is when we look at the universe and measure what we've measured, it is perfectly consistent with a universe that could spontaneously arise due to the laws of quantum mechanics from literally nothing. The total energy of the universe appears to be zero, which of course is kind of what you might expect of a universe that came from nothing. And everything we've discovered seems to...
I don't disagree with what you write, but between you and Richard Dawkins, you guys concede fully half of the argument to us creationists. And to the intelligent design folks.
And say, how can you? I mean, the question is, do you disagree with the science? And if so, what's your scientific base?
I love the science. I'm an amateur. I'm a radio talk show host for 22 years, 5 days a week. I've debated people like Michael Shermer, Eugenie Scott. Back in the 90s, Eugenie Scott was on with me for an hour, and she said the best evidence for evolution was junk DNA. And I said, the Bible teacher... I said, well, Eugenie, don't you think it's too early in our study of genetics to conclude affirmatively that all this non-coding, all those regions are junk? And she said, we have it. We sell the DVD. She said, we absolutely know affirmatively that it has no function. Now fast forward 15 years, and it's the Bible pastor who was right,
well,
one of the world's leading atheists who was wrong.
Well,
Scientist.
first of all, Jeannie isn't a geneticist.
No,
secondly,
neither am I.
I mean, I'm a little worried when people make a mistake and say something, then suddenly it doesn't mean this of all universes for the long-term future of life.
Yeah, we're able to observe.
Space is non-zero. If it was zero, the universe would be better.
Dr. Krauss, from our position, you say the sun is in an insignificant corner of our galaxy. From our position, unlike the vast majority of stars in our Milky Way, we are able to observe not only the Milky Way to an extraordinary degree, but the entire universe. We have such an extraordinary opportunity because of where we are.
Well, it's not unique by how you're right. We're lucky. In fact, we're unlucky in a way.
Yeah.
We can observe the rest of the universe, but we can't observe most of our own galaxy. So it just depends. It's like someone who lives on the other side of the tracks. It's always greener.
Well, but if we were in the cluster, right?
We can see, but we are very unlucky. We can't see what we can't see.
If we were in the cluster where most of the stars are in the center of our spiral galaxy, there would be so much interference, we might not be able to see hardly anything.
Well, the point is we don't exactly know, first of all, the conditions, what life would be like, for example, there. And you're absolutely right that if we were right in the center of our galaxy, probably not only would we not be able to observe anything,